Today's experiment is actually two experiments. In the first, we will measure out a known mass of sodium oxalate and make a solution. We will use that solution to determine the unknown concentration of the salt potassium permanganate. In the second half of our lab, we will use that known potassium permanganate solution that we determined from the first half to titrate with an unknown solution of iron sulfate. We will actually be doing two titrations. The first is to determine the concentration of the solution in the burette, and the second is to determine the concentration of the solution in the Erlenmeyer. We'll be using sodium oxalate to standardize our base. So we'll start by weighing out 0.2, approximately 0.2 grams of sodium oxalate into our two trial flasks. Tare the scale. Wait until it settles on 0. .17. And record the amount that I've added, including all significant figures in my data table. The starting mass of this flask is 90.3949. I'll record the mass, and then I'd like to add 0.2.
So 90.59. Very small amount.
And I'll record my new value, 90.5940. Next, add about 50 milliliters of deionized water to each sample and swirl until it's completely dissolved. I can use the graduations on my Erlenmeyer flask because this number does not need to be accurate. So approximately 50 milliliters. It does not change the number of moles. We know the number of moles. We can calculate it rather based on the mass of sodium oxalate and the molar mass of sodium oxalate. Next, we'll add about 10 milliliters of 6 molar sulfuric acid to each flask. One flask at a time, heat the solution to between 80 and 90 degrees Celsius using a hot plate. Heating the solution catalyzes the reaction, and its optimal temperature is between 80 to 90 degrees Celsius. While the solution is heating, rinse and fill the burette. We need to rinse our burette with the potassium permanganate solution, so I'll start by adding a little solution through the length of the burette and allowing it to run out of the tip. Then I'll close the tip and add a little more solution. Then in order to rinse the length of the burette, we'll hold it laterally and allow the solution to swirl back and forth. We want to coat the internal surface of the burette so that no water, and of course no air, lingers.
Pour into a waste beaker and repeat. Erase the burette 3 times.
And on our third rinse, remember to leave a little bit of potassium permanganate solution in the tip and check for air bubbles. There should be no air bubbles and no water, only potassium permanganate. That drip on the bottom is not a part of our calibrated value, so I can touch that to the waste beaker. And now we're ready to fill our burette.
If you fell beyond the line, you can empty down into a waste beaker to get your meniscus where you want it to be.
Once you've reached the desired temperature, carefully handle the hot flask.
The rim of the flask isn't hot.
Now we'll titrate the sodium oxalate solution with our potassium permanganate solution, meaning we are determining the concentration of the potassium permanganate solution experimentally, so through experimentation. I need to work quickly, so I'm going to turn on my stir plate and put a white piece of paper for a color contrast. My stir plate helps to keep the solution stirring. Add a stir bar. We want to keep mixing the solution so that we'll be able to recognize our endpoint. We're looking for a sustained pink color. Over titration would lead to a permanent purple color. My first solution is a little over titrated, and I've added 23.87 milliliters of potassium permanganate. I'm titrating again, looking for a lingering pink color. So we're trying to titrate so that the moles of potassium permanganate and sodium oxalate reach the stoichiometric ratio that matches the balanced equation. We know the number of moles of sodium oxalate that we measured out, and we'll use that to determine the number of moles of potassium permanganate in a known volume, and therefore to determine the molarity of the potassium permanganate solution. Potassium permanganate is known to contain impurities, so rather than just calculating its molarity, it's important that we determine its molarity through experimentation. This last drip on our burette is a part of our calculation, so I'll add it to the solution.
and we've reached our endpoint. We're looking for a sustained pink color.
Once you have collected the data for the first part of the lab, the standardization of potassium permanganate, you will use the data in that table to calculate the number of moles of sodium oxalate used in each trial. A simple gram to mole conversion will give us that value. And then from the balanced equation, we can determine the number of moles of permanganate in the unknown potassium permanganate solution, and finally the molarity of potassium permanganate, which is what we will need to move on.
Now I have a premixed solution of unknown iron 2 sulfate. And in order to determine the molarity of this solution, I will titrate it with the potassium permanganate.
We'll titrate 10 milliliters of iron 2 sulfate into our 2 trial flasks. Iron 2 sulfate is highly insoluble, so I need to keep it on a stir plate in order to keep the solution dissolved.
We have an unknown number of moles of iron 2 sulfate in each one of these flasks. That number of moles will not change if I dilute it.
For the titration to about 50 milliliters.
Since it does not change our number of moles, it will not affect our final calculations and therefore our final results. Again, I'll add 10 milliliters of sulfuric acid to each prior to titration.
This is 6 molar sulfuric acid, so I'm pouring it inside of a fume hood because it's highly reactive.
Now I can titrate the iron 2 sulfate solution with the standardized potassium permanganate. I'm going to start with trial 2 because I already put my magnet inside. Remember, I'm using a stir plate to keep my solution stirred. By keeping the solution stirred, it helps me to recognize the sustained pink endpoint that I'm looking for. And of course, I have a piece of white filter paper as a background to provide contrast so that I can see that first sustained pink color. All right, we have a sustained pink color. Trial 2, I'll record the volume of potassium permanganate that was required to match the number of moles in my iron 2 sulfate solution, and also record the fact that my solution was a little darker pink than I'd like it to be, and next time I'll stop prior to reaching the number of milliliters that I've reached this time. Go ahead and record how many milliliters was required. And my second trial, again, I'm starting at the volume where I left off, and I can just deduct the amount of solution that I add. So it's fine to leave it, to leave the amount of potassium permanganate in the burette at the previous volume, because I'll subtract the difference. So I'll stop at 50 milliliters and add more solution to allow me to continue the titration. Aha. Just 1 more milliliter needed. And record the volume.